It is the second part of section 8.2. Here, we'll consider bisecting K-means algorithm and limitations of K-means algorithms, including the basic K-means and these bisecting K-means. The bisecting K-means is a variant of the basic K-means that can produce a partitional or a hierarchical clustering. It starts with initialization, having a list of clusters containing all points. You may start with one cluster containing all points, or if we have already, if you have done some clustering, then you can start with that clustering. And here, we repeat these steps and select a cluster from the list of clusters. And for the cluster, the bisection will be run multiple times. And among them, we choose two clusters with the lowest sum of squared error and add them to the list of clusters. Okay, this portion is multiple run, and that A is a selection of a cluster. Depending on the cluster selected, the method can be different, but you may select a cluster having largest the variance, largest SSE. And the repetition will go on until the list of clusters contain the desired number of clusters, K clusters. Here we have an illustration. Now in iteration 1, we have two clusters, and now right one is selected to be bisected in iteration 2, and in iteration 3, now left one is now selected to be bisected, and then after that it has now 4 clusters. The bisecting K-means algorithm is not as susceptible to initialization issues as the basic K-means clustering. For the basic K-means clustering, initialization issue is somewhat serious, but along with this, bisecting K-means is not so much susceptible to the initialization issue. Here we consider now limitations of K-means algorithms, either basic or bisecting. The K-means have problems when clusters are of differing in sizes, densities, and non-granular shapes. And also, the K-means have problems when the data contains outliers. The outlier issue is always happen for most of algorithms. Here, this figure is showing that now 3 clusters, okay, for given data. Now this is one cluster, another cluster. Now that is the last one. But here the sizes are different, so that once you are using standard clustering algorithm, then now here you can get such clusters, and different sizes makes a problem. Now also here different densities may introduce problems. Here there are now here this is original data set, and if you are trying to get 3 clusters, then now here you may get that one. Along with this here clustering, the SSE is minimized, but apparently right now it's not really good clustering. Okay, also, here it is a non-granular shape, then is one cluster and the other one is, okay, this part is another cluster. But if you are choosing two clusters, then now it is trying to bisect in this way, but it's not really good in clustering. So here, these K-means algorithms, either it is basic or bisecting, it doesn't matter, for different sizes, densities, and non-globular shapes, these algorithms have some difficulties. Okay. So to overcome the limitations, we may try to use larger number of clusters, and several clusters represent a true cluster. For example, for this data set, we may try to get 6 clusters. Then here, there's one, and that will be now 4 clusters, and 1 here. So that these 4 clusters may represent a true cluster. And for this one also, this is a different density data set. Now we can choose here 6 clusters. Then looks like you can now make these 4 clusters represent true, 1 true, and now here separate 2 clusters. Okay. Also for this non-granular shape, here if you choose 3 clusters for each one, then these 3 and that 3 represent the other clusters. In this way, along with a larger number of clusters, you can get really good clustering. Okay. Now, another issue is around the outlier problem. The K-means algorithms are sensitive to outliers because an object with an extremely large value, for example, may substantially distort the distribution of the data. So it is quite sensitive. The solution is, instead of taking the mean value of the object in a cluster as a reference point, Meadows can be used as in K-Meadows algorithm. And the Meadows is the most centrally located object in a cluster. Rather than mean, just a member from the data set will be used. And or we may develop an effective outlier removal algorithm. We'll do it as a project. Then we'll try to combine the clustering and here supervised learning for classification. You'll do a project around here. Okay, that's the end of part 2. We'll continue in part 3. Thank you.